Hi everyone, I'm Nancy Atkinson, Senior Editor of Universe Today, and thanks for joining us for another of our live interviews via Google Plus Hangout on Air. Just a couple of housekeeping items before we get started. If you're watching this on Google Plus, if you could please +1 this so we can get an idea of how many people are watching. And you can also watch this on the CosmoQuest website at cosmoquest.org/hangouts. And if you have any questions or comments today during the interview, you can post them in the comment section on Google Plus or in the chat area on CosmoQuest. And you can also post questions via Twitter using the hashtags #CQX, #Hangout. Joining me today, as always, is Universe Today's publisher, Fraser Kane, who's manning the control booth. Good early morning out there on the West Coast, Fraser. And our
7 a.m.
7 a.m. And our very special guest today is climate scientist Dr. Michael Mann, who is a professor and researcher at Penn State University. He's the author of more than 150 peer-reviewed publications, and is probably best known for his paper in Nature in 1998, which produced the hockey stick. It's a reconstruction of past climate, which shows that the world is warmer now than it has been for the past 1,000 years. And he's written 2 books, including Dire Predictions, Understanding Global Warming, which was published in 2008, and just out is his most recent book, The Hockey Stick and the Climate Wars, Dispatches from the Front Lines. Michael, thank you so much for joining us today.
Thank you, Nancy. It's great to be hanging out.
Great. Well, I really enjoyed your book. I learned a lot, and I should show the book here. And, you know, I found it fascinating, but I also found it really disheartening to read your accounts of how you and other climate scientists have been the subject of smears and intimidations. You've received death threats and have gone under the Inquisition-like tactics of politicians. Did you feel it was important to have a chance to tell your entire story, and that's why you wrote this book?
Yeah, that's right. I mean, I felt that, I had an opportunity. Initially, I would say I was a reluctant and really almost accidental sort of entrant into the raging public debate over climate change when our graph, the hockey stick, became somewhat of an icon in the climate change debate back in the late 1990s, and then 2001 when it was featured in the Summary for Policymakers of the 2001 IPCC report. That really established the hockey stick as this icon in the climate change debate, and that meant it was a target for attack by those who seek to deny the reality of human-caused climate change. And over time, as I experienced all the sorts of attacks that you describe, personal attacks, attacks against my integrity, my professional integrity, demands for me to be fired, inquisitions from prominent politicians, I actually realized that I had an important story to tell, and it actually gave me a unique opportunity to talk about the larger issues, about climate change and the threat it represents, and the extent of the campaign that has been underway to try to discredit the science, and ultimately, look forward. What can we do about this? Both as scientists trying to make sure that we are effective in getting our message out to the public, that the discourse is informed by good and honest science. I had an opportunity, sort of within this narrative of my story, to talk about these larger issues, and I hope that that if nothing else, the book accomplishes that. It gives me sort of a unique opportunity to talk about the issue of climate change.
Right. Well, I thought it was interesting and a little surprising to read that you really weren't planning to be a climate scientist. You started out in theoretical physics, and then when you did start your work in paleoclimatology, your initial inklings were that natural causes of climate variability might be more important than...
Yeah, that's right.
Yeah. Could you talk about that a little bit? And was there a specific turning point where the science that you were engaged in and your colleagues, or was it that changed your mind, or was it kind of a gradual understanding?
Yeah, I mean, great questions. As I sort of alluded to, I really was an accidental, public figure in the debate over climate change, because I started out first of all as a theoretical physicist, and I was doing my PhD research on theoretical physics. And it was in the late 1980s, and funding for the superconducting super collider had been cut, and suddenly there weren't all the opportunities there had once been in the world of physics to work on any problem that you wanted to. Physicists were sort of getting funneled into pretty applied areas of research, and I had to decide, is my heart in it, or do I want to try to work on some bigger picture science, maybe in a different field? And I saw that there was a professor at the department in the Department of Geology and Geophysics at Yale, just down the hill from the physics department, who was working on this fascinating physics problem, the problem of understanding how Earth's climate works. And it sounded like a fascinating problem to me. It was a big picture problem. I could make use of the math and physics that I had learned to work on this fascinating problem. And so that's what got me interested in climate research in the first case. My research actually did focus on natural climate variability. My PhD thesis was focused on trying to understand natural oscillations in the climate system, and especially sort of long time-scale oscillations. And that's what led me into my forays into working with so-called proxy data, like tree rings and ice cores and corals. There's only about 100 years of widespread instrumental thermometer measurements. So if you really want to understand longer-term variations in climate, you need to turn to these indirect archives, these proxy data. And it was only when we started to work with these proxy data and we tried to actually reconstruct how temperatures had changed in the past, where we were, led, essentially undeniably towards conclusions that had deep implications for the problem of climate change, because we did determine that the warming of the past century really didn't appear to have any precedent in the record as far back as we could extend it, which was eventually 1,000 years. And that's sort of the story of how I found myself in the center of what is perhaps the largest and most contentious, although one could make a case for other areas of science, but certainly one of the most contentious areas of conflict between science and politics in the modern era.
Yeah. Now, we look back now, looking at the tobacco debacle back in the 1960s and early 70s as, there's no doubt that the tobacco industry was creating a controversy or covering up details. Are you hopeful that one day soon that, there's in your book and many other people have compared what's happening in climate science to what happened with the tobacco industry, and are you hopeful that things will turn out kind of the same way it did, that the science will eventually rule out and that people will see what's going on here?
Yeah, I have no doubt in in these battles between science and politics. In the end, science has always won out because, hey, guess what? We've got reality. We've got truth on our side, and truth does eventually win out. Sometimes it takes quite a while, and that's really the concern, I think, to many of us with respect to the climate change problem, is that we are committing right now with our emissions today to changes in climate decades and centuries into the future. And if we are to avert what some scientists who study the impacts of climate change quite closely would describe as dangerous changes in our climate system that threaten future generations, our children and grandchildren, we don't have a whole lot of time to get our emissions under control, to avoid breaching those thresholds. And so we don't necessarily have the sort of time that it took with plate tectonics, half a century from the time that there was evidence put forward to the scientific community ultimately accepting that. We don't have those sorts of we don't have that sort of time to wait to act on this problem if we are to avert what might be called a disaster. And fortunately we did act in time with respect to other global environmental problems like ozone depletion and acid rain. And it gives me some optimism that we will find the will to act on this problem in time. And so I'm optimistic, but I also recognize the very real urgency of the problem.
Okay. The notes section in your book is one of the most detailed reference sections I've ever seen, with over 100 pages of notes. So if anyone wants to check your sources, they're right there. Is that just the scientist coming out in you, or did you feel that this was very important in your case?
Yeah, I think what you see there is the struggle between the scientist and the editor. You know, me, the scientist, oh, but we have to explain how this works, and I have to back up that claim, because, you know, you can't just say something and not back it up. That is the scientist in me battling with the editor. Says, okay, well, we'll let you put it in the footnotes, but, you know, we got to get it out of the main text. Got to keep the main text. So yeah, there was that give and take, but you know, on a more serious note, you know, I knew that you know, those who have been trying to discredit me for more than a decade would be coming after me, and they already have with this book. You know, they tried to sink our Amazon reviews by posting lots of one-star sort of drive-by, you know, negative reviews of our book. The Wall Street Journal ran what is frankly one of the silliest book reviews I've ever seen. That I guess was supposed to try to pan my book, but actually came across as really a pretty sad commentary on the state of the, you know, things at the Wall Street Journal. And so there, you know, I knew that they'd be coming after me, and so I had to do the best job I could in backing up what I say, and that's part of why the notes are so detailed. And I would encourage people, you know, if you have the time, do check out the footnotes, the end notes rather, because there is a lot of interesting and important information in there.
Okay. Well, in science circles, skepticism is always thought to be a good thing. Can you talk about the difference between skepticism in science and the denial of climate change that is taking place?
Yeah, thanks. You know, that's such an important issue because, and I devote a whole chapter in the book. In fact, it's an homage to Carl Sagan in the demon-haunted world, Candle in the Dark, where I talk about that. You know, skepticism, it's just so unfortunate that we've allowed some to misappropriate that term who have absolutely no rightful claim to the mantle of skepticism. Skepticism, as you allude to, is a fundamentally important thing in science. It's what keeps us moving forward. The fact that we don't just accept, you know, when a paper is published making a surprising claim, we don't just accept it and say, oh, I guess, you know, I'll have to change what I think about this. It's subject to scrutiny. It's subject to efforts at replication, and there is a good faith, sometimes very contentious debate between scientists, but it's in good faith, right? Both, you know, ultimately it's aiming at figuring out, you know, what's right, and that's part of the scientific process. It's part of what makes science unique in many respects and what keeps it moving forward increasingly towards a better understanding of the world. And unfortunately, there are those who are looking to, you know, discredit mainstream science who've sort of tried to take advantage of that openness and of skepticism by claiming to be skeptics when they're no such thing, when they are nothing of the sort. You know, for example, they're willing to dispute accepted science like the greenhouse effect. I mean, come on, you know, Fourier in the early 19th century understood that there was a greenhouse effect. This is nearly 2-century-old physics and chemistry, and yet there are people who will say, well, you know, I just don't believe the greenhouse effect, and they call themselves skeptics. But here they're throwing out centuries of, you know, tried and true, multiply verified science, and based on often what are the flimsiest of arguments that don't hold up to the slightest bit of scientific scrutiny. And that's not skepticism at all. It's contrarianism, or in its worst form, and I talk about this quite a bit in the book, denial. And I'm not afraid to call people who are denying mainstream science deniers. They're denying something that we essentially know. And they're not skeptics. And they don't like the term deniers because it's, you know, it doesn't put them in the flattering light they'd like to put themselves in. They like to compare themselves to Galileo. They like to compare themselves to Wegener. But if you go back and, you know, look at Galileo and Wegener, these weren't, you know, mavericks who worked entirely outside of the scientific system. They were mainstream scientists and mainstream academicians, and they wrote, you know, in the case of Wegener, seminal textbooks that we still use today on atmospheric science. And they were real skeptics. And my editor actually, we went back and forth about this, and I ended up taking it out of the book. But at one point, I sort of a riff on a famous line from politics from more than a decade ago. To those who would claim the mantle of Galileo, those who dispute climate change, and they compare themselves to Galileo, is like, I've read Galileo. You're no Galileo, and they're not. They're not. For Carl Sagan, I think, put it very well. Similar sort of thing. They say, well, they laughed at Galileo too. I'm disputing climate change, but when Galileo disputed prevailing wisdom, they laughed at him too. And Carl Sagan had a great line about that. Is yes, they laughed at Galileo, but they also laughed at Bozo the Clown.
Yeah. So, well, anytime that we post an article about climate change on Universe Today, the discussion in the comment section can sometimes become so polarized with people arguing with each other. And of course, this is taking place, everywhere. Why has this issue become such an issue that people get so angry about?
Well, I think it's like a lot of these, phenomena. It's complex, and the answer I don't think is as simple as we wish it was. But there are elements of the problem that come together to sort of produce this perfect storm of sort of denial and disinformation that we see in the case of climate change. And as you alluded to earlier, it's not unlike what we saw with tobacco, where there were vested interests, the tobacco industry, that had a motive to try to discredit the science, which was linking, the use of their product to adverse health impacts, lung cancer. We have the same thing here. We have a vested interest, the fossil fuel industry, and those who advocate for its interests, who, profit greatly from our current addiction to fossil fuels. And understandably, they don't want to see that change. And unfortunately, they've chosen, in many cases, to use very underhanded tactics to try to discredit scientists, to go after, target individual scientists like myself in an effort to convince the public that the science is too uncertain to act on, and there's no reason to change the way that we're doing things. I think to some extent, this stuff is orchestrated at a certain level because they lavishly, these vested interests lavishly fund front groups that produce disinformation. They produce content on the web. They sort of have a lot of influence in certain sort of conservative-leaning parts of our media. There are networks, news networks, cable networks, news networks, blah, 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 blah. Cable news networks that you can watch that are devoted to the denial of climate change. And what you then have are people who, there are so many challenges of modern life, right? And we have economic challenges today, and they're frustrated. They may be out of work, and they're frustrated. And when they're told by those who are really looking to exploit them and to make some mischief that the reason you are suffering is because of these scientists who are trying to destroy our economy by regulation and regulating greenhouse gas emissions, and these evil scientists are trying to take away your personal freedom. And that now interacts with the fact that, as we all know, scientific literacy today isn't what we wish it was. It isn't what we would hope for. And that all those factors mix together to create a perfect storm where it's very easy for vested interests to mobilize, large numbers of people, and certainly at least half the population, and that's all you need to prevent action when it comes to policy. As long as you've divided the public along a partisan divide, nothing will happen. And that's effectively what the fossil fuel industry and libertarian organizations that are closely allied with them have tried to do. They've tried to poison the public discourse over this issue to the point where it just becomes another issue of politics and nothing moves forward.
Yeah, and in your book, you're really not shy about naming names and who is being funded by who. So it's an interesting read in that respect to just kind of see the web of how this all works together. And it seems as though the climate science is being drowned out by those who do disagree with your work. And I know that climate scientists are now making a more concerted effort to speak out more and get the word out to a wider audience. But do you think that in the beginning that everyone thought that the true science would win out over the noise and they wouldn't have to make such an effort?
Well, it's interesting. I talk about this in the book. Back in 2006 or so, there was almost like a sense of euphoria within climate scientists who had been devoted their lives to trying to inform the discourse and make sure that it was understood that this is a real problem. We can't bury our heads in the sand. And we had these devastating 2005 hurricane season. We had been setting record temperatures around the globe year after year. Al Gore's An Inconvenient Truth had come out and had really exposed a much larger cross-section of the public to the information about the scientific information and knowledge about the issue of climate change. And the IPCC shared a Nobel Prize with Al Gore. In the wake of that euphoria, sort of 2006, 2007, I think, and I describe this in the book, there was a sense of complacency that sort of set in within the scientific community. And I could face this often with colleagues. They say, that the debate, we're done with the scientific debate. Now what we've got to start talking about is adaptation and mitigation, and that's what we've got to focus our energy on, because we moved beyond that debate. And I knew otherwise, because I had been at the center of the attacks of climate change denial since the beginning of that decade because of our work on the hockey stick. And I knew these people. I knew how they operate in these organizations, in these front groups. And I knew that they weren't just about to roll over, to give up and say, oh, well, you know what? Yeah, I guess the scientists did make our case. Let's have that good faith debate about what to do about the problem now. They weren't going to do that. I knew they weren't going to do that. And guess what? They didn't do that. They retrenched. They invested even more resources. Certain corporate interests like ExxonMobil, because of all the public pressure of them funding climate change deniers, sort of ramped down their funding. But at the same time, a lot of some of the wealthiest private conservative foundations really ramped up, and I talk about them. Koch Industries, KOCH, the Koch brothers, Scaife, the Scaife foundations, Richard Mellon Scaife, they have poured hundreds of millions of dollars over the past 10 years into, like I said, creating what my colleague Naomi Oreskes in her wonderful book, Merchants of Doubt, describes as a Potemkin village. Remember those old villages in the West? They were just a facade to fool people. Mm-hmm. A Potemkin village of climate change denial outfits, all these groups that have these fancy-sounding names, Americans for Prosperity, and I could go on down the list. And most of them are funded by a small number of very wealthy conservative foundations, and in many cases they're all traced to the same P.O. box in Washington, D.C. So yeah, I think there was a false sense of complacency that set in, and what we saw was an escalation of the attacks. It's, well, okay, if science is getting stronger and stronger, which it has been, as science is supposed to, then our attacks have to be fiercer and more underhanded. And, and that's what we've seen, and that's sort of part of my story, is having lived through all that.
Yeah. Now, I saw a quote on Twitter, and I apologize, I can't recall who said it to give them credit, but they said that the hockey stick and you have been independently investigated and vindicated more times than any other facet of science. And as an example of that, earlier this month, the Virginia Supreme Court halted Attorney General Ken Cuccinelli's investigation of your work, where he was demanding all your documents and emails from the time you worked at the University of Virginia. And basically, I think he was kind of twisting the law designed to look for embezzlement of state funds and that kind of thing. However, the Supreme Court did rule in your favor and the university's favor. Could I get your thoughts on what transpired there?
Sure. The lower court had found that in his 40-page filing which is supposed to be about state fraud and ferreting out state fraud. That's what this the civil investigative demand, these civil subpoenas are supposed to be for. That's why they're there for the Attorney General. And of course, it was appropriate here because, of course, he was ferreting out the fraud, the hoax of human-caused climate change. The lower court found that in his 40-page filing, he had not anywhere provided any evidence whatsoever of any impropriety on my part, which was one would think was a substantial oversight in a document that was supposed to justify this vexatious, attack, not just against me, but the University of Virginia, Thomas Jefferson's university. And ultimately, in the higher court sort of ruled on a fairly narrow issue, but the lower court really made the key determination in the first place that he hadn't provided any evidence of wrongdoing other than the usual misquoting of stolen emails that we've seen for years now to try to make it sound like climate scientists have been fudging data, and there have been, I think, 8 investigations into that, including the National Science Foundation Inspector General, who said, no, we looked at these allegations. There's no, there's absolutely no basis to them whatsoever. You're simply misrepresenting what scientists were saying to each other in these stolen emails. But he used that in part as justification for this, what the Washington Post, I think, characterized as a witch hunt. In fact, they ran 6 editorials blasting Cuccinelli for, ultimately what he was doing was wasting millions of dollars of taxpayer money on this, politically motivated witch hunt against me and the University of Virginia. And what's so ironic is just think about, and the University of Virginia was forced to spend hundreds of thousands of dollars in defending itself. What if those resources had instead been used to help Virginia deal with the threat to the Chesapeake Bay posed by the impacts of sea level rise that we're already seeing, and adapting to the rising sea level and the threat to the Chesapeake Bay? What if we had instead used those resources for something constructive, to act rather than using them to try to bury our head in the sand about the problem? What if Virginia taxpayers had instead had the resources used to actually do something about the problem? I hope that will be going through the mind of Virginia taxpayers as they choose their next governor.
Mm-hmm. Yeah.
Of which Cuccinelli could potentially be one candidate.
Oh, okay. Could I ask you about some of the science of the talking points that some climate change deniers usually bring up? And we've been asked these on University, and I'd just like to get your input. Some of them say that carbon dioxide is such a small percentage of our atmosphere, 0.038% about. How could the change in something that small make such a big difference? Well,
arsenic is deadly in just parts per billion. But we don't say, oh, well, it's such a tiny amount of arsenic, it couldn't possibly hurt. The point is that we understand, it's not even, if you believe that if you come at this problem perhaps from a different ideological bent, sort of conservative bent, and you don't trust the scientists, you don't even trust Fourier back in the early 19th century, and all the other, and Arrhenius, and all the other scientists who have built up our current understanding of the greenhouse effect and climate change. You throw all that away, but perhaps you might still, trust the U.S. military, okay? Well, the Air Force, back in World War II, needed to understand the greenhouse radiative properties of CO2 in the atmosphere. Turns out if you want to design an effective heat-seeking missile, you have to understand the absorption spectrum of infrared radiation in the atmosphere, because the missile is seeking infrared, a target that's glowing in the infrared region. So the U.S. military understood the greenhouse effect of CO2, and they had to use it to help us be victorious in World War II. It's just remarkable that there are some who still don't recognize that this is science. It's 2-century-old science that we've understood. We've understood it for nearly 2 centuries, and we use it. We have to use it even in the military. We have to understand that even a small amount of CO2 in the atmosphere has a very profound impact on the radiative balance because of the characteristics of those molecules.
Right. And some other people say that that it's arrogant to think that humans could change the planet.
You know, I hear that argument, and fortunately, it was even espoused by the NASA administrator under the former administration, Griffin, who said something to that effect when he was interviewed, I think, on NPR. He said, "Well, it's arrogant for us to." I think it's arrogant to, you know, when we look from space at the Earth's atmosphere, you know, the Apollo mission allowed us to, you know, to see, you know, that our atmosphere is this fragile, tiny, thin little blue layer around the planet. And isn't it arrogant to think that we can be pumping gigatons of carbon into that small, that tiny little shell of atmosphere and not be influencing its composition? And of course we know we are. We have records, we have modern records of CO2, we have records from ice cores and other direct lines of evidence that allow us to actually estimate how CO2 changed in the very distant past. And we know that CO2 levels now are higher than they've probably been in several million years. Okay? So we, you know, not only can we know we are fundamentally changing the composition of the atmosphere. And it's a little bit of arrogant. It's a little arrogant of us to think that we can do what nature did naturally over 100 million years and bury carbon that was in the atmosphere in the ground and gradually lower CO2 levels from the high levels that existed in the early Cretaceous. So nature can change CO2 on a time scale of 10 to the 6th years. Isn't it a bit arrogant of us to think that we can unbury it on a time scale that's 1 million times faster and not have some profound impacts on our environment and our climate? So I'm frankly always puzzled by that statement. It just belies, I think, a lack of appreciation of the profound influence that we have today. And you know, if you look at from space at the Earth at nighttime, you see, you know, all these lights. We know how fundamentally we've changed the Earth. We can see it in satellite images of the Earth. We are fundamentally changing this planet, and you know, we can bury our heads in the sand, or we can recognize the profound impact that we're having and the consequences that that impact may have.
Okay. Another comment has been that the sun, climate scientists don't really understand how the sun affects our planet, and that it may have a greater effect than that we realize.
Yeah, well, you know, some of my research has actually been devoted to understanding some of the subtle impacts of changes in variations in solar output. And in fact, I've worked with scientists at the NASA Goddard Institute for Space Studies in understanding some of the more subtle mechanisms by which changes in solar output can influence, for example, the pattern of the jet stream. And so you can get large patterns of regional cooling and warming that have to do with the way the jet stream changes. When you change solar output and you modify the amount of ozone in the stratosphere and you change the vertical temperature profile in the atmosphere. So, you know, one of the areas that one of the most vibrant areas of climate research is actually understanding natural impacts, for example, from solar output changes and all the subtleties that may, accompany those changes. And you sometimes hear the claim made that, well, scientists are ignoring that. No, I mean, we actually use, a lot of my research is based on trying to use our understanding of how the climate changed in the distant past in response to natural factors like solar output changes or volcanic eruptions to inform our understanding of how the climate will respond to other factors like increasing greenhouse gas concentrations. And there's an important role to be played in studying the past to inform our understanding of the future. But if you're getting down to the question of, you know, the influence of the sun, you know, hey, we've got several decades now of of direct measurements of and not just the overall solar output, but the spectrum, the frequency spectrum of changes in solar output, the broadband changes versus the changes in the UV. And we know what the overall change in radiative forcing has been with those changes in solar output, and we can measure the response of global temperatures to those changes, and we know it's consistent with our basic physical understanding that solar output changes by a small fraction of a percent on timescales of decades and longer, and global temperatures respond by a very small amount, maybe 1/10 of a degree Celsius, in response to those changes in solar output. A colleague of mine, Stefan Rahmstorf, about a year ago published a paper in, I'm trying to remember the journal, I think it was journal, the Geophysical Research Letters, where what they did is they looked at a scenario over the next century where suppose we entered into a grand solar minimum. That's the granddaddy of solar impacts. It's like what we had in the early 17th century, what we call the Maunder minimum, when there were no sunspots observed, when we know that the sun was inactive, in an inactive phase of its cycle, and solar output was potentially several tenths of a percent lower than it is today. And if you put that into projections of the future, if you imagine that we entered into a grand solar minimum over the next 50 years, that would have a cooling on the order of maybe 0.1, 0.2 degrees Celsius in the global average temperature. And the impact, if we project our current CO2 trajectory forward over the next century, we'd be talking about several degrees. So the impact we're having on global temperatures through increasing greenhouse gas concentrations is literally more than an order of magnitude larger than the impact of these variations in the sun, even if we imagine the largest possible, based on past analogs, solar impact on the climate. And so, yeah, the sun has an impact, volcanoes have an impact, but it's minuscule compared, as my colleague Richard Alley likes to point out, right now we've got control of the most important knob, and that's the CO2 knob, and we're turning it up. And it's a much larger controlling knob than any of these smaller knobs.
Okay. Well, you end your book on a hopeful note that things seem to be getting better as far as the attacks on climate scientists and that kind of thing. Are you hopeful for the future, or are you more worried about what might happen if we let climate change go unchecked?
Yeah, I am optimistic about the future. I realize we have this monumental challenge ahead of us. If we're going to transition away from a carbon-based economy on a time scale fast enough to avoid breaching dangerous levels of CO2 in the atmosphere, we have to get that underway quickly. And so there is a real urgency to the problem. But I'm also optimistic, in part, as I alluded to earlier, because we've confronted past global environmental threats like ozone depletion or acid rain before they became catastrophic. And I think we can look to the past for some optimism that we will rise to the challenge with this with a problem that's of a much greater magnitude than anything we faced, admittedly. But I still think we can look to the past for optimism that we will confront this challenge in time.
Okay, great. Fraser, do we have some questions from the comments or chats?
Yeah, I've got a couple. I know we don't have a lot of time, so I think we're probably only going to have time to tackle one question.
We can do two. I can stay a little late here. Yeah.
Sure. Okay. So, a question from Joe Scaife, no relation. How can climate scientists help drown out the nonsense in the media? And I was actually going to ask a very similar question, which is that it seems like an almost evolutionary arms race. I see like an analog in almost parasite-host relationship that the two are kind of working. So how has the denial activity improved the ability and the communication skill and the science?
Yeah, it's a great question, and I really like your framing of it, because I think that is a very good analogy. Is this escalation as the other side steps up its tactics? We scientists have to become that much better. We can't play by their rules. We play by rules of honesty and fairness and openness, and that's what science is about. And when you're dealing with an opponent who has no respect for the facts, has no respect for the principles of honesty that we hold, dear as scientists, it means there's an asymmetry to this battle, and it means we have to be that much better than them in terms of explaining in clear language the nature of the problem, the degree of confidence we have in the reality of the problem, the magnitude of the problem, and what we need to do to solve it. And I am to some extent encouraged by what I've seen over the past few years in response to the increasingly vitriolic attacks against scientists and against science. We've seen the scientific community rise to the occasion. I mean, we've seen the National Academy of Science as a very stolid, scientific body founded in the 19th century by Abraham Lincoln, Republican President Abraham Lincoln. We've seen the National Academy of Sciences come out with some of the strongest statements imaginable, condemning the anti-scientific attacks against the science of climate change and the tactics that are being used to try to discredit and intimidate individual scientists. And we've seen the AAAS, American Association for the Advancement of Science. We've seen leading scientific societies like the American Geophysical Union, the largest scientific society in my field, the American Meteorological Society. Across the boards, we have seen the scientific community stand up in support of the scientists and to fight back. And to fight back by confronting disinformation and disingenuousness when it is encountered in the debate over the science and its implications, providing resources for scientists to fight back, to become better communicators. And I was extremely gratified that my good friend and a leading climate scientist and a leading communicator of science, Gavin Schmidt of the NASA Goddard Institute for Space Studies, just this last December won the very first Science Communication Award, a new award provided by the American Geophysical Union, implicitly recognizing how important communicating science has become, not just in our field, but I think across the boards. And it was the feature award. It was the award that got the most attention at the entire AGU Awards ceremony, and I think that speaks volumes. And the number of sessions at that conference, or the number of sessions at the most recent AAAS meeting in Vancouver, just the amazing number of sessions about outreach and education and fighting disinformation and scientific integrity and making sure that scientists aren't intimidated against speaking out. I am very encouraged by what I'm seeing, and it gives me optimism that we will prevail in this asymmetric war that we're engaged in with those looking to discredit our science and to discredit us.
Okay.
And one more, I guess?
Yeah, let's do one more. Okay, so this comes from Graham2128 on Twitter, and he wants to know, Michael, at what approximate CO2 concentration does the risk of positive feedback runaway climate change become significant? So, if you were to, I know that there was a sort of line in the sand that we've crossed, but, where would you put the line in the sand right now?
It's a great question. It's one I get often, and it's a difficult one to answer because there are a number of elements to a proper answer to that question. First of all, we know that there are positive feedbacks related to the melting of ice, related to more water vapor in the atmosphere. Water vapor is a greenhouse gas, so you evaporate more water vapor into the atmosphere, you magnify the greenhouse effect infrared. So on balance, positive feedbacks win out over the negative feedbacks in the context of anthropogenic climate change. You get more warming than you would expect just based on the CO2 you're adding, the absorptive properties of the CO2. But we don't think that Earth's climate, or at least anywhere near the regime that we're in today, although some colleagues will disagree with this, but I would say the prevailing wisdom in the scientific community is that we are not in the domain of a runaway feedback like Venus underwent. Venus evaporated all of its water vapor into the atmosphere. It experienced a runaway greenhouse effect, and that's why it is the hothouse planet that it is, an unlivable planet. We don't necessarily think that something like that could happen to Earth. But there is the other side of it that I think the questioner is alluding to. There's the issue of what we call tipping points or thresholds. The climate is not entirely a linear system. It means that if you push it just a little bit, at certain times the response can be very large because you cross some sort of tipping point, tipping element in the climate system. And some examples of that are the melting of permafrost, the release of the methane that was trapped within the permafrost into the atmosphere. Methane is also a potent greenhouse gas, and so that increases the greenhouse effect even more. It's a positive feedback. It amplifies the warming. The melting of the ice sheets. If we set in motion enough warming, if we lock in enough warming, we may set in motion a sequence of feedbacks that are essentially runaway feedbacks that will lead, to a total destruction of the Greenland ice sheet and a large part of the Antarctic ice sheet. And then we're talking, 20 or more feet of global sea level rise. And so there are these potential tipping points that loom out there that if we cross, well, we won't become Venus. We would see, impacts that certainly are in sort of the very high cost, sort of catastrophic end of the spectrum of impacts. The thing about tipping points is you don't know where they are until you reach them, right? And so the safest approach that we can take is to limit the warming as much as we can because we don't know precisely where those tipping points are. But what we do know is once we cross them, it's too late. And so that's, I think, cause, among other things, for the precautionary approach to dealing with climate change and for getting our emissions under control, as quickly as we can, while obviously, smoothly transitioning to a new energy economy. We can't, go cold turkey on fossil fuels, but we can get in place all the incentives we need to make sure that we move towards a non-fossil fuel-based energy economy as soon as we can.
Okay. Well, I think that'll wrap up our interview today. Thank you very much, Michael, for joining us. It was really a pleasure to talk with you.
Thank you. It's been my pleasure.
And
thanks a lot.
we want to thank you for your work and the stance you're taking and your ability to communicate this important science to the public.
Thank you so much.
All right.
See you guys.
Well, thank you again. Thanks, everyone, for joining us.
Okay. Bye.
Bye.